Right, so now now that we have defined our heuristic function, without further ado, we'll start constructing our state space tree. So to construct the state space tree, we are going to go job wise, and we'll go job 1, job 2, job 3, job 4 in that sequence. When we are computing the heuristic value, we will look for the global minimum. So this might sound a little confusing because when I was talking about heuristic and choosing the minimum of minimums and all that, I said you will not look at the jobs in any sequence. Now I'm saying we'll go in the order job 1, job 2, job 3. So let me make that clear first. So like I said, in a branch and bound problem, you will first define the heuristic function. You're not going to calculate anything using that function. You will just define it. You will define how that function works, how it will compute a certain value, what value it computes. Then you will construct the state space tree level by level, and then at every level you will apply the heuristic, right? So I defined the heuristic using this minimum of minimums something approach. So keep that aside, remember it, but we're not going to apply it right away. We will first build the tree and then apply the heuristic. So to build the tree, we have to go in some hierarchical order. We saw this back when we were doing backtracking password example, which you're all familiar with by now. We did 0 dash dash 1 dash dash. We guessed the first digit. Then from there we guess the second digit and so on. So for the tree, to build it, you need some hierarchy. So for that, again, we will go job 1, job 2, job 3, job 4 in that sequence. So initially we'll take job 1. What are we trying to do? You want to allocate this job to one of the workers. So what are the possibilities we have? Job 1 can go to worker 1, worker 2, worker 3 or worker 4. 4 possibilities. So your state space tree will look something like this. If you look at the first image on the slide, J1, you have W1, W2, W3, W4. 4 states are here. You need to compute the bounds or using the heuristic function. So we assume these bounds are not computed yet. I'm going to tell you how we compute them. So initial tree looks something like this. You have J1 and you have 4 possibilities for it. So you've set up the initial part of the tree. Now we will use our heuristic function to compute the bound for each of these options. So we'll start by assuming we assign job 1 to worker 1. And we'll try to compute the heuristic. So what does this heuristic mean is, assuming I've assigned job 1 to worker 1, within the remaining 3 jobs and 3 people, what is the minimum cost I require across all configurations? So if you remember when we were discussing this knapsack example with regard to the heuristic function, I said the heuristic is defined as, assuming I've taken object A, what is the maximum profit I can make using any combination of the remaining items? Or assuming I have not taken object A, what is the maximum profit I can make using any combination of the remaining items? Similarly here, assuming we have assigned job 1 to worker 1, what is the minimum cost I will incur using any assignment of the remaining 3 jobs to the remaining workers? Assuming I have assigned job 1 to worker 2, what is the minimum cost for any assignment of 3 jobs to 3 workers, and so on and so forth. So that is what your heuristic function physically signifies. Okay, so now we will compute the heuristic function for each of these options. We had 4 options, remember. First option is job 1 goes to worker 1. So this is the same table which was given in the question. I have simply copied it here. Job 1, worker 1 has been assigned. We are assuming that is fixed. So that cost is a 9, which is fixed, and we don't look at that row and that column because we don't need them anymore. It's a 1-to-1 mapping, remember. Now we look at these 3 jobs and these 3 workers. We will look at the global minimum. It is a 1, which is worker 3 and job 3. So we will map worker 3 and job 3. Now again, you assume that row and that column are deleted. You look at 4, 7, 6 and 4, I think. Again, the next minimum is this 4, worker 2, job 2. Do that mapping. Again, remove that row and that column. The only thing left is worker 4, job 4. So by using the global minimum at every step and then removing that row and that column, you get this assignment. So if we go by this order, we get J1, W1, J2, W2, J3, W3, J4, W4. So these diagonal elements. So 9, 4, 1 and 4, if you add them up, your cost is 18. So for the first option, assigning J1 to W1, your heuristic function gives you a value of 18 units. So if this is the sequence in which you are assigning things, you will have to pay a cost of 18 units.